Good morning and welcome. Today is day number 4, and we are going through some details about video, um, the video capability, output video capability of the GMA structure. So let's start with slide number 1. Um, as as I told you in the past days, the system is working in two main ways. One is 12G main program output, and the other one is to have HD main program output. The two outputs are exactly identical at the same time in terms of video contents and of course and of course audio content also. Uh, but to get that, we need some form of protection against failure. So this is the reason why we have two main embedder identical. Our two board 7814 from Everts. 7814 it's the generic name, um, but the two board can be equipped with a lot of options, and we have all these options like audio management, like video processing and management, and so on. It is, in other words, a very complex board. So, as I told you, the two boards are identical. Then let's analyze just one. Video embedder has a 12G video input and digital audio input on 8-channel AES. The 8-channel for the embedder 1, the 8-channel AES comes from audio mixer number 1, and for the embedder number 2 comes from audio mixer number 2. Um, if you look at in CR1 and also in CR2, there is a small area with two identical mixer in it. It's they are mixer number 1 and mixer number 2. Of course, they can be used separately or together. In normal event, should be used together, and that means if on audio mix number 1 I have on channel 1, 2, 3, 4 some microphone, the same microphone should be present on channel 1, 2, 3, 4 on audio mix number 2, because uh, one mixer is live on the main program and the second one is the backup. If something happen, there is an automatic system that we will see in the next slide, which will change between the audio mix 1 and audio mix 2. For the same reason, we have the two embedder with the 12G input, but in the embedder number 1 we have a direct switcher program output, and on the embedder number 2 we have a video router output, program video router output. That means the two 12G are identical in terms of video content, but one is from the video switcher, the other one is from video switcher to the router to the embedder. The output of the embedder, so the embedder board has two identical output. Each board has two identical output on four wire 3G each channel. It's a quad output. The first 4x3 SDI output goes to the what we call the main 12G path, and the output number 2 goes to the main HD path. So, but at this level, here and there, signal are 12G. This one is used for real 12G output. This one is used uh, for the next stage where will be converted to the HD. But at this level, we have 12G on both output, on both embedder. 12G here, 12G here, 12G here, and 12G here. Quad mode on 4 wire. Any question? Okay, let's go. Oh, sorry. Okay, here we are on the second slide where we have um, a more detailed system. As I told you, we have video switcher which give us an output which goes to the Everts router, and then from the Everts router goes to the embedder number 2, and we have a main output which goes directly to the embedder number 1. We still have here audio from audio mix 1 and audio mix 2. This 4x3 SDI, now we are talking about this main 12G path. This main 12G path for embedder 1 and embedder 2 is this one, main embedder 12G. Okay? This is the output that we are talking about now. The stage the stage after the embedder is another board which is called ACS from Everts also, and it is used as changeover. This board is able to receive 4-channel video, which is 12G on one side, and 4-channel video on the other side. There are many software options inside the board which make the board very, very, very configurable. In our case, the board will receive a control command from an external keyboard where we have 3 buttons. Green and yellow button do the same thing. The red one, it's different. So this side is related just to the the 12G side. In normal condition, we have the main output goes to the main output from the video switcher goes to the embedder number 1. Audio mixer number 1 supply the audio. Then we have on 4 wire video and audio embedded. This signal goes inside the changeover, and then the changeover give us 2 identical output, always on 4 wire quad, always. We have our content audio video here and our content audio video there at the same time from technical point of view, from the video and audio point of view, the two outputs are exactly the same. Oh, sorry. Okay. There is one main difference between the two output, but is not in terms of contents video or contents audio. It is represented by this bypass. So this bypass, it's a relay system which is inside into the board. Uh, Please, Marco, can you exchange on the whiteboard? Yeah, thanks. So let's imagine we have the video on 4 wire which comes in into the board. Okay? Then inside the board, let's consider just one video channel, not more. There is a sort of switch which normally video goes to the output through the processing. But the board itself is built in this way. We have a back plane and we have the board itself. The board itself can be extracted from the glue shelf. And of course, if you take out the board, I should expect to have a black signal on the output. But really, this not happen because these are the output of the board. Then normally what should happen is signal in goes here, goes into the processing board, output of the processing goes to the output. But there is also this small switch which is in the back of the board. When you extract the board, the back still inside, and automatically this one will be connected to this point and we have video output. So for the first 4 output, these are the second 4 output, we lose video from we lose the video from the board itself, but we still have a bypass signal here. That means if we take out the the ACS, the changeover board from the glue frame, okay, this relay will bypass automatically the video, and then we have this video which comes in here and comes direct out here on the output, on the main output. This is a protection system because, please Marco, can you exchange back? Okay. Because the changeover is built to protect the signal from any troubles that we can have here or there. So if we have a problem here, if we press the red button, the system will exchange on the second input, and then we still have the 2 output. But what happens if the changeover itself goes in fault? Well, what happens is the bypass relay will be activated and then the video here goes directly on this output, even without the board inside. So that means we have three level of protection. The first level is given us by the tool path and the presence of the two embedder with identical contents, audio and video. The second level is represented by the changeover, because if one embedder will be in trouble, or this main output will be in trouble, and then if this output is in trouble, of course this embedder is in trouble too. Manually we can exchange on the second one. The second one is receiving the video signal from another output from the mixer. That means if we are in trouble with this output, of course the embedder number one will be in trouble, and of course this one we have no signal. But we can exchange on the second one, where the output comes from another output through the router, and then we have signal output here. If something happened on this video switcher, that in other words we lose completely out 1 and out to 12, of course what we expect is to have no signal here and no signal there, but we still have the possibility to route on the output 47 maybe the video camera directly through this router control panel. If you look on the video desk in CR1 and also in CR2, in front of the control panel of the video switcher, there is a small router control panel. This router control panel, we saw it yesterday how it works. It works in this way. This router control panel controls just output 47. On the key number 1 here we have camera 1. On the key number 2 we have camera 2. On the key number 3 we have camera 3, and so on. Then we have PWS, we have some other sources. What does it mean? If you press the button 1 on the output 47 of the router, appears the camera 1 directly, not through the video switcher. That means if the video switcher is in some way in fault that we cannot use in any way, we can simply have the output continuity just using this switching bar. In normal condition, to use the video switcher, the last button will be active. Last button means input 19 routed to the output 47, and input 19 is the video switcher output. Then in normal condition we have output 1, which goes to the Everts router and then goes through the router. This button is pressed to the output 47 and goes to the embedder number 2. Main output goes to the embedder number 1, and then we have audio from mixer number 1 and audio from mixer number 2, two identical signal audio. The output on 4-wire quad output arrives at the input of the changeover. The other output from the embedder 2 arrives to the input of changeover. This input in normal condition is not used, but the changeover is switched on the input number, sorry, on the main input, and we have two output identical. If something happened on this side, we don't know if it is this main output, this cable, or the embedder. We don't care. We just notice that we have a problem, and instantaneously we press the red button, and the changeover will exchange between this point to that point. Of course, here we have the signal present, the correct one, and then we have a continuity on the output. If something happened that we still not have uh, we still have a problem because the changeover itself is has a problem, there are two possibilities. Uh, the changeover has a built-in capability to detect its status. If the changeover will detect its status wrong, automatically will activate the bypass. Then we lose this output, but we still have output here through the bypass. If this action is not working for some reason, what we can do is to pull out the changeover, and the bypass will act instantaneously, and then the picture should be appear here. Any question?
Yes.
Hello?
Hi, Maurizio. I have a question.
Yeah, yeah,
Maurizio, please, if something happened with the embedder number one, and
yeah.
and and
Oh,
no,
sorry.
please, the other one, and the changeover also is broken. So
Yes.
here we work with the backup without changeover. There is no bypass.
Without changeover, without board changeover, there is no bypass.
So is there
So,
any
sorry,
method?
sorry. Wait a minute. Wait a minute. Without the board inside, you have a bypass on the output number one.
No, not all the board, only the switch inside to change from embedder number one to embedder number two.
You mean this switch?
Exactly. If this is
Okay.
broken and there is no signal from embedder number one, so we
Yeah.
have the obligation to work with embedder number two, and there is no bypass. Is there any method to change manually the bypass from the changeover in the first outside to the second one?
Yeah, there is a way, but it's not so fast.
You need to change the cable on the back
Yeah,
directly.
yeah,
And
yeah.
it's four cable. You remove four and you replace with the second source.
But still possible.
Yes.
Yeah, of course. Yeah,
Maurizio,
absolutely,
please,
yes.
is there any method for troubleshooting to detect where is exactly the problem if we lose the signal in one of both?
Yes, there is. Um, but it's so what I suggest to you is at the end of this training course, this is just a suggestion, of course. Uh, I mean,
Yes, thank you
if
for
you
that.
want, you have to go inside in EQR1 because EQR2 it is exactly the same theory or the same thing, and explore by yourself all the wiring and how to manage that. There are a lot of ways to understand if we have this output working, if we have this output working, if the input of the embedder is working or not through the software, because there is a lot of software inside, and you can check the status of each board on the computer. It's so complex. Is not so is not a simple question. The problem is um, you have to train yourself to do it um, many times, and you go through the system, and then you can discover by yourself all the necessary way uh, in which you can understand if something is working or something is not working. Considering that these are broadcast equipment and uh, they should work. I mean, of course, if there are some disaster like a temperature problem, uh, power problem, or something else, of course, it's just pieces of electronic that can be damaged in some way. But normally, this equipment will work. Uh, Of course, is it possible always to add a new level of security? But just at this level, we have three levels of security, and adding a fourth, I mean, it makes nonsense in some way.
It's already
Normally,
four, Mauricio,
yeah,
because the bypass is not inside the board. It's on the
no, the
frame,
bypass it's on the
on
back
the back.
plane.
Yes. Bypass
You can pull out the
ماهوش في
board and the
الكارتة
bypass is still
في
active.
الفريم. Okay,
Of
Mauricio, thank
course.
you. Continue, please.
Maurizio,
No, I
please,
mean,
one other question more.
yeah,
For HD outside, we work
HD,
with the
yes.
same changeover equipments or is another one?
In the next slide, we will see it. Next
Okay,
slide.
thanks.
Wait, yeah. But please, uh, I recommend you, at the end of the training course, if you have time and you want to spend some time for yourself, not for, I mean, just to training yourself, um, Omar and Marco can give you schematics. You have the system. On each schematics, there are wire, and each wire has its number. Then it's easy to understand where the wire come and when the wire goes. Then you can go on the back of the rack and check this wire, what it does. You may try to disconnect it and see what happened. It's just to put your hand inside, to be familiar with the system. I
Yes, my
suggest
pleasure.
this one. I suggest this one to you.
It was a pleasure.
It's a really good way to understand the system and be able to manage any condition.
Okay,
Okay,
thanks for your advice.
so this is another small pieces that we had, which is if you look at this big area now become this small area here, okay, and because we had, you remember, at the output we still have 4 wire from the board. I mean, the changeover will exchange the video, yes, and audio embedded, yes, but the output of the changeover still on 4 wire, but the GMA system works in 12G on 1 wire. So that's the reason we have to add at the output two multiplexer, which takes 4 wire and put the digital information on a single wire. This information, it's our program, and it goes on router 61 input, and then the other side goes on router 62 input. So this is another level that we can use just to have a help, because let's imagine that we have a problem on the embedder 1. The embedder 1 goes inside here, and we press the red button, then we exchange to the embedder 2. That means this output still present on the router 61 and input, and on the router 62 input. Well, but if we have a problem with the multiplexer or with the router 61, then we can use input 62, because on the input 62 we have the same program with the same contents and the same video contents and audio contents. So it's just take a moment to switch every input, every destination which receive 61, to have to switch on this destination input 62, and then we can continue with the event. This is an adding that we have. Any question? Okay. Now we can go through the system to check the HD part. So let's consider this area. This 12G on 4 wire, in this case, it is not this one, but it is this one, as we have already seen before. The embedder 1 and the embedder 2 has two output on 4 wire. Until now we have talked about this output. Now we are talking about this one, the second output, which is this one. So again, we receive video from the video switcher exactly the same as before. We receive audio from the audio mixer exactly as before. Then we have the second output of the embedder, which goes to the HDRC 4000. Here we have 12G on 4 wire, which goes inside this machine. HDRC 4000, it's a very complex machine from Sony. That processor can do 2000 things. It's a very complex, a very complete one. We use it to transform the 12G, sorry, okay, the 12G 4K signal in HD signal. It's just, it is not just a matter of uh, change from the number of pixels from 4K to HD, which of course changed pixel number in the picture. But the HDRC is able also to make a change on the dynamic range because the 4K is high dynamic range, but HD it's a standard dynamic range. And then the HDRC 4000 is able to change from to make the conversion from number of pixels downgrade, downscale, and also downgrade of the dynamic range. What we have at the output, it's a pure HD signal in terms of dynamic range and pixel number. The HDRC has two outputs, and we use both. Now we have to spend some words about the changeover. Uh, Please, Marco, can you exchange on the whiteboard? So, um, this is the changeover board. Changeover board has two, three, four, and one, two, three, and four. So it can work. It can work in two different way. One way is 2 by 4, and in this way, the changeover will consider one video channel, this one, and one video channel, this one. So means that uh, when we have a 12G signal with four cable connected, and we want to exchange between one and the other, we have to exchange together four video channel. That means this is one video channel and this is another video channel. But the changeover can work also in 8 by 1, in which it consider each channel which arrives inside as a single video channel. Then this is video channel 1, 2, 3, 4, 5, 6, 7, and 8. Of course, this is from physical point of view. From logical point of view, this is video channel 1, 2, 3, and 4 on the secondary input. In our case, we are using only channel 1 and 2 because HD signal we have on the output of the HDRC two signal identical HD in input 1 and input 2. That means the output is switched. We still have two output as before, is switched here or from here. The philosophy, it is exactly the same. Simply, the board is configured differently because we'll manage a single video channel on a single wire instead of a single video channel on 4 wire. This is important because the two boards are identical from a technical point of view and hardware, but you cannot exchange directly because the settings on the board, of course, are different. In case of trouble, you may decide to lose the HD output and bring this board to and insert the board inside to use it for the 12G, but you have to remember to load inside the settings to allow this board to work in 2x4 instead of 8x1. Any question? Okay.
It's okay.
Now we can see the external slide for the changeover.
1 second, Maurizio, please.
Okay. Here we are.
Let's change over.
Okay. This is a part of the schematics, a small section of the video schematics about the changeover, embedder, and so on. Now we have to go through that one. So let's consider first this part. Okay. This is the video mixer, video switcher, in which we have output 1, which is our program, and the output 1 goes to input 19 of the video router. Then we have program. This one is identical to that one, completely the same thing. On output 12, which goes directly through a cable to the embedder 1 input. On the router, we have set that the input 19 is connected to the output 47. That means we have a video from here, program, which goes directly to output 47. Output 47 goes inside the embedder number 2. And then we have on embedder number 1 program and on the embedder number 2 program, but from two different sources. One from the video switcher directly, the other one from the router, from the video switcher through the router. Now, the main embedder has 4 output, which is one channel video 12G, but it's on quad signal, configured as 2SI. That means, if you remember what we have already seen days ago, in 2SI, in quad mode, if I cut this connection, 1/4 of the screen become black. But in 2SI mode, if I cut this cable, just the quality decreases a little bit, but I still have the entire picture. This is the reason why we use 2SI um, encoding system instead of quad. Of course, this is selectable inside into the software of the main embedder, and is also selectable inside the software of the video switcher. Maybe in the next week, when someone comes from Sony to show you the video switcher, one of the first thing that we will show you is the main settings, and you will find that the main settings output is 2SI signal. Then the 4-wire goes to the changeover input A link 1, input A link 2, input A link 3, input A link 4. We have also the from embedder 2, we have output 1, A, B, C, and D in 2SI, which goes to the input of input B link 1, input B link 2, input B link 3, input B link 4. So this is the situation that we have seen before on the slide. At the input of the changeover, we have embedder 1 and embedder 2. Then, in normal condition, program out A link 1 is working. 1, 2, 3, and 4. And this one goes to the multiplexer number 1 to the router input 61. But we still have also, at the same time, this output. Um, then these 4 input are routed on program out A and program out B. So means we have picture here for router 61 in and for router 62 in. If something happen and we press the red button, this input A link will be cut out, and the program out A and program out B will receive video signal from input B link 1, input B link 2, input B link 3, input B link 4. And then we still have signal here on the multiplexer for router 61 and on the multiplexer for router 62. Any question? Okay. Now, from let's assume that we have a program here. We have on the embedder another output. At the same time that we have output 1A, we have output 2A. This signal goes to, for the embedder 1, to the processor number 1. And processor number 1 give us 2 HD output. At the same time, the embedder number 2 supply its secondary output to the processor 2. Then we have a quad signal to SI here and 2 HD output. Well, after the processor 1 and processor 2, sorry, After processor 1 and processor 2, we have a changeover, another changeover board, which is set as we have already seen, and goes to the output HD goes to the router 63 and to the router 64. So if something happened, exactly what we have seen here, if something happened on processor 1, the changeover will switch to the processor 2 and the output 63 still present, even the output 64, because um, the changeover has two output at the same times on program A output and program B output. Exactly like what we have seen here. We have four cable active here and four cable active here at the same times. So the philosophy of the system, it is exactly the same, but what change is the number of wire involved, because the system in 4K works with 4 wire and in HD with just 1 wire, but the general philosophy still the same. The last part is this one. It's Everett's control panel. So let's imagine that at certain point this video switcher, for some reason that we don't know, go in fault mode, goes in fault mode, and then we lose this output and that output. Using this Everett's control panel, we can exchange. This Everett's control panel will control the output 47. If this last button is pressed, means output input 19 to output 47. If someone press the first button, means input 1 to output 47. So input 1 is camera 1. That means on the output 47 appears 12G signal for camera 1 directly from the BPU. And then we have camera 1 here on the embedder. And then on the changeover, because we have exchanged it, we have camera 1 which appears. And we can use this bars as well, not as a switcher because it does not function like a mix, wipe, title, and so on. But we can exchange the various sources to the output directly, even if the real switch video mixer is out of order. Any question? Okay.
Good morning, Maurizio. I have a question.
Good morning.
So, if the video, we have problem with the video mixer, and we
Yes.
want to use the control panel,
Yeah.
how can we display the signal on the equyware control room?
Um, when you use the control panel,
Yeah.
the each button you press, the signal goes in program mode. Then you still have a program output.
Yeah, I want to see what's on the program.
Sorry, I cannot understand. You won't see?
What's on the program?
The program is the output of the multiplexer on router 61 and 62.
Yeah, how can we do to see it on the display?
Oh, it's automatic. I mean, you have a multi-viewer. If you look, if you look into the CR1, there are multi-viewer with the program in preview on the multi-viewer. I mean, if you lose the video switcher, the two multi-viewer for the video switcher in the center of the room probably will not work. But on the side, left and right, you have the multi-viewer from Everts where you can have the program output. If you look on the multi-viewer on the right, looking the video switcher desk on the right, if I remember well, there are 4 video which are program 61, 62 for 12G and 63 and 64 for HD. Then you have the 63 and 64 for 12G. Then you can check the signal directly on the multi-viewer.
Which is connected to the video mixer.
No, I'm talking about the multi-viewer connected to Everts, not to the video mixer.
So can you provide steps or the schemes to follow? Or it is already connected?
No, are already connected. No. The program out 63 and 64 are already connected to that multi-viewer. Then if you move also if you route also the output 61, sorry, if you route input 61 to monitor 48, you have the quality control monitor on the right side of the control desk, video control desk, which show you the program. We have program video input, input 61, 62, it's 12G. Input 63 and 64. On output 48, here, you have connected the monitor for the quality control. If you route 61 in 48, you have the output of the selection bar directly on the monitor, quality monitor. You still have, of course, on the multi-viewer, but in this case you have also on the quality monitor.
Okay, thank you.
Okay. Of course, on the quality monitor it's easy to have it because also the quality monitor can work as the embedder. Then you can have also audio on the quality monitor. Okay? Because you have to consider that.
And you can check
let me
the
go.
quality of the signal on the wave meter also, on the same time.
One thing that it's important is that one. If you use this bar, you have to use maybe this one is camera 1. Okay, I select camera 1. Then my video output at this point is through the embedder 2 is camera 1. But the audio input still from the audio mixer. That means you have on the camera one picture embedded the correct audio signal. You don't lose the audio signal if the video switcher goes off. Is it clear?
Maurizio, please.
Yeah.
If the video mixer is still working well,
Yeah.
and I want to push Evers to work, it can work or not?
You mean if the video switcher is working and you press this button?
Exactly.
Yeah. Well, there are two possibilities. So, if you are working with the video switcher and with the embedder number 1, nothing happened. You can press anything you want that the output still good. But if you press the red button and you have this button pressed, video switcher work and everything is fine. But even if the switch is working and everything is fine, and you are working with the red button, and you press any other button, your output will change. Follow the router, because this one controls the router. Then this output is according to the selection here. This is the reason why in normal condition, this button should always be pressed and this panel never touch.
Maurizio, if we have a problem with the red button,
I have no answer. I mean, if you have a problem with the red button, means probably you still have a problem with the changeover itself, because the red button is just a push button with two wire. There are no electronic. If the one wire is broken or you have the connector disconnected, of course, when you press the button, the control will not reach the changeover. Of course, what you can do is go into the software, and through the software tells to the changeover exchange between A and B, because you can do that through the software, through the control panel on the software.
so still we have a chance to do it.
Yeah, not immediately, but you still have a chance, yes.
Thank you, Maurizio.
Okay,
Mauricio,
you're welcome.
please. They ask
Omar?
if we lose the router,
Yes,
what's happened?
if you lose the router, yes. If you lose the router but you have a mixer video working, then you have normal condition. Of course, if you lose completely the router, you lose the output, because the output goes to the router 61 and 62. Then you have to connect manually. So if you look at this multiplexer, we have two outputs. Then
One on the router, one on the patch panel.
we have an output on the patch panel, then you have to use the patch cord. Yeah.
Yes, thank you.
But what I what I suggest to you is bring the schematics and slowly, one, two wire, three wires per day, not more, not a lot, uh, 10 wires per day maximum, and um, check the philosophy of the system. Of course, this is important for this system, okay, but generally speaking, this give you an idea on how to check and work on a complex system. So let's go on. Any other question?
Thank you.
Okay. So, and then we can start with the AQR2 system, CR2 system. So, um, we will see just the differences between AQR1 and AQR2 system because mainly the two system are identical. So what we have seen for embedder, the embedder, PWS, and so on, philosophy and connection are the same. Schematics are also the same, but what change is cable number, of course, and there are some differences where the two systems will manage different equipment. Then we will see that. The entire system in EQR2 is divided into the equipment room where we have 5 rack instead of 6. Then we have a control room number 2, and in control room number 2 we have Shotoku system and camera control, but we don't have a Vinten because Vinten control is only present in CR1, the control for the camera, the external camera on the minaret. Then we have a graphics video mixer, exactly as CR1. PWS, which is called server in this case, we have two PWS 4500, and of course a quality control station. We have an audio mixer in a room separated from the other room, exactly as we have in CR1. And we have another part which is not present in CR1, which is edit 1, edit 2, and archive. This part will be intended or will be used for both, not only for AQR1 AQR2 CR2, but this part is useful for the entire system of GMA broadcast system. I mean, the archive should archive contents from CR2 auditorium and contents, of course, from the pre-roll or picture from the camera from minaret or whatever. So this is a general area useful for the entire GMA complex. Okay. Now we have some differences between AQR1 CR1 and AQR2 CR2. So main difference is the number of cameras. We have 16 cameras in AQR1 CR1, but we have just 4 cameras HDC P43 in AQR2 CR2. Of course, a different number of camera means different number of BPUs and CCUs. Um, Means 4 camera has 4 BPUs and 4 CCUs, but we have a different 4 different type of camera, which are camera 8 HDC 4300. This kind of a camera is of the same family of the HDC P43. That means um, the philosophy of the camera and the characteristics of the camera are exactly the same. For instance, the CCD sensor, the same for the both model, but the P43 is a point of view camera in a fixed installation. The 4300 is a studio camera. That means can be a shoulder camera or can be a tripod camera. Another point, uh, it's a movable camera, not for fixed point. Of course, 4 camera means also 4 BPUs and 4 CCUs. That means the total of BPU and CCU in EQR2 is 8 instead of 16. That means we can save space for one rack. This is the main reason why we have um, 5 rack instead of 6. We have just a
It's
one Shotoku control station. One Shotoku control station, in reality, we have 2 Shotoku control stations, but means we have Shotoku control station and not Vinten in this case. And here we have Vinten control station in EQR1 CR1. We have some device which are used in EQR1 CR1, but also in EQR2, but the electronic is in EQR1. MediaNet Riddle system is used also in EQR2, but sorry, the core of the system is in EQR1. The mesh patch panel is in EQR1. If you want to have a different mesh configuration in EQR2, you should do it. You can do it, and you should do it, but in EQR1. Then we have the intercom riddle system, which intercom riddle artist, which is the main electronic for the intercom, is in EQR1. Of course, we have also intercom in EQR2, which can talk with EQR1, which the some area, satellite area with the talk and so on. But we have the control panel here. The core of the system, the electronic, is in EQR1. So what does it mean? That means that EQR1 has a sort of technical prevalence. In other words, if the power is cut in EQR1, some services still working in EQR2, but the major part will die because EQR1 has a technical prevalence. Any question? Okay. This means you cannot say, okay, for this mount, I want to use just EQR2. I can switch off EQR1. Not. You can switch off some device in EQR1, maybe like camera, BPU, CCUs, but other device must still in operation. Otherwise, you lose service also in the other area. Between EQR1 and EQR1 and EQR2, there are some lines with audio, video, and controls. Of course, these lines over fiber. We have from Bâtiment M the GPS which arrives to the Equerre 1, and there are two fiber which from Equerre 1 goes to the Equerre 2 to synchronize the generator inside Equerre 2. We have from Taco Bivan uh, signals directly interfaced with Equerre 1, but some signal, sorry, just a second. Some signal are from Taco Bivan directly to the Equerre 1 and vice versa. For some other, like Dante Network or MeteorNet, that means audio, pure audio, or audio and video with the MeteorNet, the interface, main interface is a QR1, but through these lines, we also have a QR2 connected directly to the OBVAN. Why I have put some green arrow here? Because it's important to understand this one. In TOC OBVAN, we have a terminal block for the triacs. We will see that tomorrow. But just to anticipate to you, we have a triacs from TOC OBVAN which connect some areas, external satellite area. But as you can see, we have not triacs to Equerre 1 Sierre 1 and triacs to Equerre 2 Sierre 2. So that means, sorry, that means triacs are always point to point from each satellite areas to the OBVAN. There are no triacs in Equerre 2 Sierre 2, and there are no triacs in Equerre 1 Sierre 1. What we have from the satellite area, SMPTE cable to the Equerre 1 Sierre 1, point-to-point connection, even in this case. But we don't have any kind of camera cable, triacs, or SMPTE from the satellite area to the Equerre 2 Sierre 2, or from satellite area to the Equerre 2 satellite area, like Auditorium, Edit 1, and Edit 2. Is it clear? Any question?
Maurizio, please.
Yeah.
For the sensible services between EQR1 and EQR2, we have passive links or active links or both.
Good question. Yes, both. We can say we have both. For yeah, we have some link which are defined and you cannot change it, of course. Like the mesh, uh, riddle mesh, you cannot touch it.
Read the
Right?
mesh,
So
it's active.
yeah, just a second, please. Marco, please, could you change on the whiteboard? Okay, so let's consider this one. Oh, yeah. No, why not? Yes. Okay. So we have, let's consider just EQR1, EQR2, not the other area. We have, oh, sorry. Yeah. We have a patch in EQR1 and a patch in EQR2. Two patches are connected with a 24 core fiber. Mesh, riddle mesh, provide to have a certain connection here. So wait a minute. These two patch, no, is wrong. My drawing is wrong. Wait a minute. Wait a minute. My drawing is wrong. Okay. Now it's better. We have here we are in AQR1. Okay. And here we are in AQR2. Okay. This red square is also AQR1. So we have a 24 core fiber which connect this patch to this one. Of course, this one is in AQR1 maybe 3 meter long, no more. But we have another 24 core which connect this patch in AQR1 with a patch in AQR2 with a patch in AQR1. This is maybe 1000 meter. That means each position here is related to the similar position here. 1 is 1, 2 is 2. Mesh require to connect some position here to another here, or vice versa, as we saw in the last days. Of course, we can consider this connection fixed and active, and we cannot disconnect it. Otherwise, you lose your MediaNet mesh, and the entire MediaNet system will collapse. But there are some other lines. If you remember, I told you that we have from the router 8 lines which goes to the router here, or 8 lines from this router over fiber which arrives to the router here. They still on patch, and we have a patch cord connected to get that. But it is made possible if you don't use this one of this output or more to move this patch to another position and send to the router input on the QR2 not the router output but another video sources. give you this give you a lot of flexibility. Is the right answer?
Yeah, clear, thanks.
Okay. Uh, Again, if you bring the schematics and you check equipment by equipment, uh, well, you will be familiar with the system, but also you can discover some workaround or some flexibility that you can put in place in emergency or along the preparation of the event. Okay. I think we may have a break for 15 minutes.
The repose liquid.
Okay.
Okay, thank you.
Thank you.
Thank you.
Can we start?
I think yes.
Okay, Omar, I need your help for a minute.
Yes, please.
Do you remember in 2022 when we have prepared for the national television the
Yes.
camera on the minaret for the 5 juillet, the
Yes.
anniversary?
Yes.
Okay, I would like to take this event as example
Okay.
to show the flexibility of the system. So, uh, then if you can help me to explain to them the position of the obivan and so on, but I try to do through this drawing.
Okay.
Um, our actual position of the top obivan is this one. Then there are some stairs here. Then the AQR1 more or less is located here. 500 meters away, we have the minaret with the 4 camera. At that time, the television, asked me for to have on their OB van, which was positioned in this area,
Yes.
to have a signal from the minaret camera. Of course, the signal, the minaret camera are working in 12G, but the signal to be supplied to the national television will be HD.
Yes.
At that time, what we have done, because of course all the camera on the minaret are connected straight to the AQR1, not to the base of the minaret, but
Yes.
to the AQR1. Now, the solution was found to install from Algeria Telecom. They put a fiber, if I remember well, 8 or 12 fiber
12. Yes.
from AQR1 for 500 meters to the rear of the van, of the N television van.
The HD car.
Then, sorry?
The HD car.
Yeah,
The master.
sure, yes. So the problem was how to send the 12G signal in HD mode to separate signal, 4 signal in this case, to the OB-van. So what we have done was on the rear of the BP, this is, for instance, is camera 16, which is on the minaret. Camera 16 has a BPU with 12G output. But the BPU is also able to send out HD signal because it's a it's a video processor itself. Then we have set the software inside to send the output not in 12G but in HD to the router. Then if you go on rec number 2, if I remember well, on the first fiber patch panel, the first 8 position are router output. Then the camera now comes into the router in HD mode. Remember, the router can handle 12G and HD without any settings, is transparent. So that means if I route camera 12G to output 33 of the route, sorry, 33, better if I write down, 33 of the router, output 33, it's a fiber optic output. Then, let's say is this one, we have installed, was links, the interface, Omar.
Yes, yellow break links.
Yeah. Okay. Uh, we can install an interface. Well, it's better to do in this way. With a small patch cord, we have connected this optical output to the telecom fiber.
Yes.
And after 500 meter, on the rear of the OB van, we have put an interface which give us coax. So in this way, the HD signal from the BPU goes into the router, goes on the output 33 of the router, which is a fiber, was connected to the telecom fiber, 500 meter, converter to coax, and then inside into the mixer of the NTV van. Why I show you that? Because uh, if the customer of, if your event has a special requirement which is not maybe I had to say it seems to be not allowed by the system. If you know the system and its possibility deep in deep, you can always find a workaround to have what you are searching, what you are looking for. This is the reason why I'm inviting you to spend time in study the system, the connection, wiring, and the machine possibility. Because it's not useful for normal event. It is useful when someone asks you something different. And you may say, yes, I can do it. No, I can't do it. Or yes, I can do it, but I need, in this case, we can do it. But what we need was the 500 meters cable posed by Telecom, Algeria Telecom, temporary for 5 days, no more. Then they took out. Any question?
Maurizio, please. In this
Yeah.
case, if the cable was installed from Algeria Telecom from EQR 1 to the OB1, normally we already
No,
have a fiber.
Uh,
Why we need
no,
Algeria
no,
Telecom?
no, no. Wait. There is one thing missing. Look, the our Obi-Wan talk is here. Okay. If you
Okay.
look the plan, the area plan, here we have a QR1, and here we have the Obi-Wan talk. Of course, we have a fiber here. Yes, you are right. Okay, but the television, uh, for some reason, I think technical reason about satellite or whatever, they would not use this one, but they put their Obi-Wan in this position, 500 meter away.
I think it was more than 5 meter, 500 meter.
Yeah, more or less.
1 kilometer, I think. 1 kilometer or more, Maurizio.
Yeah, probably. I don't know. It's so far away. I remember.
And
I walk many times
yes,
back and forth. It's so far away.
and we
And
send them for camera signal from the minaret, and we take back the program from the HD card, Obi-Wan, and we send back the signal of the program and camera 16 to the president screen. It was in the top of the bridge.
Maurizio, please, in similar case, what's the maximum number of cameras we can send like this?
it depends.
It
It
depends of the
depends.
bandwidth of or the
No, because
capability of
each
fiber.
camera use one fiber. Each camera has one fiber. The limit is,
Maurizio,
let's say,
Maurizio, sorry.
let me go.
Can you
Yeah.
fix your microphone?
Oh,
It's too
sorry.
far.
Yeah, sure.
Thank
Sorry.
you.
Um, the limit is not represented by the fiber itself, but let's consider we have from 1 in theory to let's consider 7 plus 2, 7 cameras in pre-roll, 2 camera in the core, and then we have, sorry, 7 here, 2, and we have 4 camera here in the minaret. Let's imagine to use all these camera, okay? The limit, and as well, considering the Obi-Wan from national television in HD, okay? Then we can set the BPU output instead of being 12G to get output in HD. So that means on the router, input 1 instead of being 12G is HD. This means that HD is compatible with national television. But to reach such long distance means 500, 600 meter, 1 kilometer. Of course, we have to use fiber. There are no other way. But from the router, the installed router, we have only 8 fiber output. All the other are on coax. That means we may have 8 camera directly from the router. But if you want to connect more, let's imagine that in this case we have some fiber from Algeria Telecom, in this case here. Okay, the first 8 I can connect directly to the router. But for the other, we have to use coax, sorry, coax output with converter fiber and go there. So we can, but what we need, okay, the fiber from Algeria Telecom. That's is not a problem. I mean, they come and they install it. But the problem is to have the converter because you need converter here, but also another converter here to give coax output again to the obivan. See, this is one of the way on how to do it. Tomorrow we will see a special device that we have uh, that was not present at that time but is present now, which is called fly case.
It was not ready, not present.
It was not ready, yes, but now is ready, and you can use also fly case. Fly case allow you to connect the fly case on the MediaNet network, and each fly case use 12 fiber, and on each fly case you may have 8 or more video channel. So what does it mean? You can use this solution, or you can use a fly case. You put a fly case near the obivan with 12 fiber, and on 12 fiber you can send audio video from EQR1 to fly case and from obivan to EQR1, including intercom. But all these options, uh, you need time. So when someone asks you, we have to do it, we have to do that, we want to do that, is it possible or not? You need some time to study the situation and found the best way on how to do it. This is the reason why there are many possibility and many flexibility, but you can put in place the best solution, which is always a compromise between quality, possibility, cost, and time. But the base to do that is a great knowledge of the system. You have to know very well the system and the equipment inside.
Maurizio,
Any
please.
question?
If we install one fly case in the garden, for example,
Yes.
and we connect 8 external camera to that fly case,
Yeah.
and the UNTV car is in the obivan or another place, what's the steps
Yeah.
to send all that signal to the television?
We have two fly case. You can install one fly case in the garden and then another near the obivan. Of course, if the obivan is not near the talk, if the obivan is near the talk, then you don't need the fly case. You just connect the obivan to the talk directly. Let me get back. Okay. If you consider that, more or less in this position, we have a wall box in the esplanade, if this one is the minaret. Okay? You can install a fly case here. Then, if the NTV obivan is near the talk, the fly case through the wall box send the data to the EQR1, and from EQR1 the data are going to the talk, and then you can connect directly without use another fly case here.
Maurizio, please, in EQR1, this will be automatic connection, or I have to change something in EQR1?
No,
in fiber.
because you simply through the MediaNet network, you can say this channel from fly case number 1, channel 1, video 1 should go to the talk micro NUHD output number 2. And then you have a coax connected between micro NUHD number 2 to the obivan.
Without passing by the switch, or we should always pass by the switch?
You need
The
only
video
switcher.
switcher,
Sorry.
it depends. If someone require to you to have some video effects like dissolve, wipe, title, or whatever, you should pass through the video switcher. If someone told you, no, I want the camera direct without anything in the middle, then you can send directly from the fly case to the talk.
Clear, thanks.
But remember, please, yeah, I know, it's my point, but the system is too complex. You have to training yourself on the system about the equipment and the cable and connection, equipment characteristics. Only in this way you may answer to the question, the main question, can we do that or not? Or please prepare 3 cameras from the garden and 2 cameras from the esplanade, and we have to go to the talk. The camera from garden should pass through the video switcher with title, but the camera from esplanade should go directly from the esplanade to the talk and then to the obivan of the NTV. It is possible, but first you have to study it on the table, on the paper, but to study it you need to know very, very well the characteristics and the possibility of the system. There is no other way. It's clear?
I have a question, Maurizio.
Yeah.
What are the points where we can connect the fly case to be part of the mesh network of MediaNet?
Yeah, the point are all the MTP12 connection. Let's give me a second. Give me a second. If I can, I show you. I don't remember where, but I have.
There is 6 on the garden.
Yeah,
box.
there are 7. No, 6 in the garden, 7 in the esplanade.
Esplanade, 2 on the minaret.
2 on the minaret. Yeah,
11
that's all.
on salle
Yeah.
de prière. Should be 11.
But I should have something that we saw in the last day. Just a minute, I have to find out where is it. I don't remember exactly. Maybe here. Maybe. I don't know. Um, Omar,
Yes?
please, if you check, maybe it's faster. If you check into the paper, the printed out paper,
Okay.
where is it? The wall box for the esplanade.
The old one, not today.
No, yeah, I think they won.
Okay, check with Marco. Marco, you have day one?
No, io sto cercando l'immagine della wall box. Okay, wait a minute. I show you one thing, just a second. Okay, you can see this picture.
Yes.
Omar?
Yes.
Yeah, okay. So, this is just an example, but okay. Oh, there's not, the definition is so not so high. Yeah, but in this case, yeah, we have. Fly keys are connected with the optical MTP12 connection, and everywhere you have an optical MTP12 connection, you can connect a flybox. We have optical MTP12 connection in the prayer hall on each column. We have 6 optical MTP12 connection in the garden and 7 in the esplanade. And then in every place that you have
Floor box.
the optical
or wall box.
MTP12, you also have the power con
كاين اللي سوري
connection
ماوريسيو
to supply power,
لي بوزيسيون عندنا في
and then
البلان
you can connect
وين
the
كاين
fly
كاع
case.
فلور بوكس ولا وور بوكس عندنا كيما اللي شفناه نهار بريمي جور اه ما عندناش تما عندنا في الاسبلاناد ار سي زيرو في لاكاج ديسكالي هذاك الوقت السيستم تاع البرودكاست ما كانش واجد 100% شغل كنا نانستاليو والحق ليفينمون هذاك لي فلايكاس ما كانوش واجدين باش نقدروا نوتيليزيوهم مع السيستم باش نعطوهم لي سورتي ولي زونطري سي بون دوكا واجدين دانتي ميديور نات عندنا جو بونس 4 اونتري و 4 سورتي اوديو اكس ال ار وعندنا الريو 1608 في شاك فلاي كاس وفي شاك لوكال ابار اي كيو ار 1 اي كيو ار 2 عندنا 32 الكبير فيه 32 انبوت و 16 اوتبوت 24 اوتبوت اي ريو ياماها دانتي سما ريو ياماها ريو يوتيليزي بروتوكول دانتي بور لوديو و انتركوم بارتو بور كومونيكي داكور Thank you, Mauricio. You can
Another
continue.
important thing is if you connect the fly case, um, fly case works on MediaNet, but MediaNet is not related only to EQR1 CR1. You can use maybe fly case in the garden and send a signal to the EQR2 in auditorium because it is on the MediaNet and it is ubiquitous. It can go everywhere.
And we can also send the signal from EQR1 to the fly case in the garden if
Yeah,
you
of
want to
course.
install a monitor there to see or have something special installation to do. Thank you.
It's okay?
Yes.
Okay. Please, Marco, can you exchange on the slide? Okay. Next slide is, well, there's the drawing of the rack present in the in EQR2, of course. And as you can see, we have just one rack with the BPU and CCUs inside because we have just 8 machines instead of 16. This is why we have one rack less. This is a video switcher, which is the main difference, not from a technological point of view, but from position of the equipment, is that if you remember 2 days ago, or no, the first day, we saw that the system is built with one frame which contains one board for the router, and on the left there are 3 boards for the multi-viewer. If you check on the paper that you have, you will find this picture. For some technical reason, in this case, in AQR2, we have the same configuration. I mean, router and multi-viewer. But having 8 camera instead of 16, we need one board. We need just 2 multi-viewer instead of 3. That means we have 2 boards instead of 3. And we have 2 frame. One is this one and the other one is that one. Instead of have a frame very big with the board, router and the multi-viewer together inside, we have one frame, this one, with the router inside, just one board. And we have one frame, this one, with 2 board inside, multi-viewer. The multi-viewer board and the router board, sorry, and the router board are exactly the same that we have in EQR1. So, in theory, you can take out this board, router board from here, and insert that board into the multi-viewer of EQR1, and vice versa. Even for the router board, even for the multi-viewer board, the board itself are exactly the same. The only thing change is the frame, the container. But the board are exactly the same. Of course, in theory and in emergency, you can do it. But the problem which is that the board in EQR2 and the multi-viewer in EQR2 are set completely different from the board in EQR1 and multiviewer in EQR1. That means just swapping the board, you cannot do nothing. You have to set completely the board from the beginning. But from electrical point of view, are exactly the same. And also, the router board, from electrical and optical point of view, it is the same of that we have in EQR1. Means we have coax, SFP with coax, and SFP with optical. This is a way the two router can send one to another picture through the optical connection. Then we have frames for glue, 4 frames, exactly configured the same that as we have in EQR1. We have the 2 processor which give us HD from 12G, HDRC 4000 from Sony, and we have a lot of patch panel, we have a radio camera, and so on. The same equipment that we have in EQR1. And this is Chiron, the graphics computer. So main differences are from the image point of view is 1 rack less, 8 camera, and the router and multiviewer divided in 2 different frames. Any question?
Maurizio, please, I remember one thing outside of that. If, for example, one fixed camera is broken, and I have no choice to buy a new 4K camera, I have only HD camera. How can I do that, and what I should change in the installation?
So you mean 112G camera is out of order, you mean?
Exactly.
Okay? But is out of order the camera or the BPU or CCU?
No,
Let's
the camera. The camera is broken.
Okay. Normally the camera are, if you have an HD camera and the HD camera is compatible with the SMPTE, you can connect directly to the BPU.
Without change anything.
Without change anything. Of course, your output will be HD.
Yeah.
But you don't need to add cable or change anything. Because SMPTE cable is a standard. And it works with 12G or HD. Of course, the difference is the resolution, but from an electrical point of view and optical point of view, it is exactly the same, without any differences.
How can I confirm if the camera is compatible with the PPU or not?
Oh, this is, well, if you have a Sony camera, 99% is compatible. If you use Ikegami or other camera are compatible from optical and electrical point of view. That means you will not destroy the camera, of course, but maybe you have not signal because the protocol is different, and you have to ask to the supplier.
It's depend to what exactly? Just for the protocol, or there is something else?
No, because on the SMPTE connection, you don't have only the video. Through the SMPTE, you have a lot of signal from BPU, CCU, and camera, which controls the camera, controls all the internal parameters. And this is the problem, it's not the video. Video itself, it works always. But it's if the CCU says uh, stay black, the camera stay black even if you are on the light and there is a picture, you know? This is the problem.
Clear, thanks.
Before to exchange, camera, it's better to check with the provider, with the supplier, or on the datasheet if there is a compatibility between one and the other. Also, if you want to use a Sony camera, uh, it's better to check the compatibility, always.
On the manual, you can find it. If this camera,
Yeah,
this
on the
model
manually
is
on the
compatible with this
internet
CCU
site, or
BPU.
maybe at the end of the day, you may ask directly to Sony
If you
in any
want to
way.
buy new camera from them, they give you the exact the exact model that you can buy to use it with the BPU and CCU.
There is another way, because let's say I have a camera with the SMPTE and the camera is not working, but CCU and BPU are working. Well, the complex camera, CCU, and BPU, those three elements are called camera chain. Okay? Then what you can do, if you are not able to find out a camera compatible with the BPU or CCU, is bring a new chain completely. So maybe let's say you want to use Ikegami, then you bring camera Ikegami and CCU Ikegami, okay? And you replace the CCU into the rack. At video level, the CCU Ikegami, it's always compatible with the installation that we have done.
With the mixer,
Of
with the
course,
router.
the RCP is not compatible. You have to install RCP from Ikegami. But from video point of view, reference, video out, tally, and so on, it is completely compatible because it's a standard.
SMPT standard.
It's okay?
Clear, thanks.
Okay. So this is what this new slide is what I told you before. The main difference on those two frames about the router and the multi-viewer system, of course. There is one board here, which is a router, and two boards here, which are multi-viewer. From power point of view, AQR1 and AQR2 are exactly identical. There are some multi socket installed into, and as we have already seen, there are many equipment which has two power and some equipment with one power. But there is a UPS as usual. UPS, yeah, this is important point. UPS is not intended to work without power because it has
Maurizio,
only more or less 20 minutes, half an hour time, but
Maurizio,
is intended
please.
in case of problem to be used to switch off everything and power down the computer, shut down the computer in the proper way. Because the risk which is, if you don't shut down the computer in the computer, everywhere there are computer there. Chiron itself, it's a computer. Magnum server are computer. There are a lot of a Pier 1 computer which control PWS.
Maurizio,
The,
sorry.
yeah,
I want just to re-explain the main function of the CCU and the BPU.
you want to do?
You or me, no problem.
Oh, I'm doing, yeah, sure, no problem. In let me have a picture. Just a second, please. It was day 3. I don't know. Maybe. I need just some second to check the right picture. Yeah. Please, Marco, can you switch over the... You can see my picture now?
Yes.
Okay, you have already this picture in your paper.
Mm-hmm.
The BPU is a sorry.
Baseband.
It's a video processor, and the CCU is a control camera unit.
Yes.
Normally, we have CCU and video camera connected with SMPTE cable, or in the past, CCU connected to the camera through the triax cable.
Triax, yes.
Yeah. In our case, we have two devices because our system is working in 12G, and CCU is only working in HD or maximum 3G, not 12G. Yes. But CCU is still fundamentals because all the camera controls are coming from the CCU, not from the BPU.
And also the power of the camera comes from
Also,
CCU.
yeah, the power for the camera through the SMPTE cable. So, in our case, we have the RCP, which send the controls to the CCU, and the CCU send controls to BPU and then to the camera. But the BPU give us the 12G output, which is not available on the CCU. So this is the reason why we have a CCU and BPU. In a normal condition, normal system, HD or 12G, maybe on the television OB-van also, they have a CCU which can be in this form or in another form, but it's always a CCU directly connected with triax or SMPTE to the camera. They don't have BPU because they don't need it. In our case, we need it. And this is the reason why we have both. If you if you want to exchange your camera because it's not working with another one, maybe HD, it may be possible that you find a camera and CCU, but you don't have a BPU. Then you just connect the video output of the camera, the video output of the CCU to the system.
Directly, without BPU.
Without a BPU, right.
Yes.
Without a BPU, yes.
I think this is all.
Maurizio, please. For SMPTE connection, the control unit send power always in SMPTU because we have fiber plus power. But in our case, we use only fiber. In which step we stop power? The equipment can't detect that, or it's the converter?
It's the HK. Yes.
No, we send the power always. Why you said we stop power?
In our case, for example, building A, we connect only fiber. We don't need power.
To the camera.
Yeah.
This is why we use HKCU.
In our case, because we are using a point of view camera, we have the camera connected with the fiber because the camera from Sony has built with this interface, not SMPTE. This SMPTE cable will power the Sony HKCU SM100, and from this device we have just fiber. This is the reason why we use a local power supply for the camera. But in normal connection, maybe if you use, instead of P43, you use HDC 4300, which are in the auditorium, but you can use everywhere. There is not this device, and the SMPTE cable goes from BPU directly to the camera, and the fiber will transport data, video, audio, controls, everything. And the power is always present on the camera until the cable is connected. If you look on the side of the camera, near the power button, there is LEDs. If you connect the just you connect the SMPTE cable with the camera off, this LEDs goes red. Means be careful. Camera is powered, but the local switch is off. And on the CCU, there are two LEDs on the CCU, there are two LEDs. One is red when the cable is not connected or cut. The other is red when the cable is in short circuit. If you have the cable not connected to the camera, the CCU show you that the cable is not connected, it's red. But when you connect the camera and the camera is off, the two LEDs are still off. Because from CCU point of view, everything is okay. If the cable is not connected to the camera, the CCU does not provide for power. That means on the cable there is no power inside.
This is my
Because
question.
the
So the
CCU
equipment,
allow the power only when the camera is connected.
so the equipment control that, not the HKCU, not the transceiver.
No. The CCU control that.
Perfect. Thank you.
The SM100 HKCU is just a converter between SMPTE to fiber and back.
Exactly, because it's not logical to control that by a transceiver. Normally, each equipment can detect that there is a camera in the other side or not.
Yeah.
Thank you.
Okay. So, another question about that. Okay.
It's okay.
Now, in EQR1, EQR2, in EQR2, CR2, our signal source and destination are only in the building D, means are only within the building, the polyvalent building. So this is why we have some connection into the auditorium, and these connections are on the floor box. Now, the floor box are in this position. Okay. And then near the stage, we have, well, First, floor box are coupled together 2 by 2 always. We have 5, 11, 3, 9, 4, 10, 6, 12, or here 1, 7, 2, 8. So uh, the differences between the floor box, maybe 1 and 7, is the connection that these floor box will supply. Technical speaking, from floor box from 7 to 12 are dedicated to the fiber connection, and floor box from 1 to 6 are dedicated to electrical connection. But we will see that later later on. Position that you have here are the floor box. Then that means if you want to connect something from the auditorium to the EQR2, you have to use these floor box. This is very important because as we have already seen before, we have 4 camera PTZ in a fixed position into the auditorium. We will see later where the camera are, but we have also 4 camera that we can put those camera everywhere into the auditorium on a tripod. Of course, if we have a camera, maybe we want to put a camera here in this position, we have to use an SMPT cable connected to the nearest floor box. Each floor box contains 2 SMPT connections. That means on each floor box you can connect 2 camera. But the total camera that we have available is 4. That means you can connect 1 here, 1 here, 1 here, and 1 there, or 2 here and 2 there, as you wish. That's not a problem. But the total amount of camera that we can install, we can connect, not install, connect, is 4. Now, let's say, Marco, please, can you switch? Okay, thank you. Okay. Here we have floor box. It's better if I show you one thing. So this is one floor box, and this is another floor box. This is in the picture we have floor box number 2 and floor box number 8, just as example. Number 8 contains fiber connection MTP12 and SMPT connection plus power. Then we have, this is wrong, is not HTTP, is optical connection core duo. Please correct your paper. Those two are optical connection core duo. And all the boxes from 7, 8, 9, 11, and 12 are dedicated for fiber and power. Why we need power? Because if we connect the SMPTE cable, the camera will receive power from the SMPTE cable, that we don't need this power. But the floor box can be used for other equipment. Let's imagine we have some BNCs here from EQR2. We have Ethernet from EQR2, and we have some audio from Dante network. If in a floor box I want to connect a monitor, then I can send to this monitor a signal from EQR2 on this BNC. But of course, monitor needs power, and then I can get power from here. I can put an audio monitor, a speaker, but then I can get audio from this output, but the speaker needs power to be amplified. And then I have this one. Or simply, I want to have a computer to check or control something along an event. Well, I can use this connection, Ethernet, but my computer works on battery or I need power. This is the reason why there is a large choice of possibility within the two floor box. Each couple of boxes are identical. We have the same combination of connection. Any question? Okay. Marco, please, can you switch to the other? Okay. In one of the, okay, we say this, we have floor box here, and then we have this one, which is Acer 01. So this one is what we call the backstage rack. The backstage rack, please, Marco, exchange. The backstage rack is something, sorry, just a second. Which has installed some fiber patch, Ethernet patch, a Yamaha Rio interface with audio, and a small connection panel. So every fiber connected into the floor box are terminated here. Let's say an example. We have, let's say, floor box number one, floor box number two, as we have seen before. It has 12 fiber for the MTP12 plus 4 fiber for Core Duo. And all these fiber are connected on this panel. Then we have on the rest of the connection floor box number 3, 4, uh, 2, 8 was the fiber, then 7 or 9, and so on. That means all the fiber connection to the floor box are on this panel, not directly connected in EQR2. They are connected on the stage, backstage rack. That means MTP12 here and core duo fiber here are terminated over this panel for each floor box. The last panel, this one, has a fiber connection from backstage to the EQR2. That means if you want to send a signal from a floor box to the EQR2, you have to connect the position here to there, and then in EQR2 routing with the patch, fiber patch, from here to destination that you want. um, this is what happened. We have MTP12 Core Duo Floorbox 7 connected on fiber patch 4 position 1U to 12D. For Floorbox 8, the same connection are on fiber patch panel 4 position 13U to 24D. So one patch panel with 24 LC duplex will cover two floor box. And then we have floor box 7, floor box 8 on the fiber patch panel 4 on the backstage. Floor box 9 and floor box 10 on fiber patch panel 5 on the backstage. And floor box 11 and 12 on fiber patch panel 6 on the backstage. For technical reason, this is not fiber patch panel 1, but it is for fiber patch panel 4, 5, and 6. Okay, and then we have patch panel 7, which is the last one, 4, 5, 6, and 7, which is connected with the fiber patch in EQR2. Then, if I want to connect something from a floor box to EQR2, I have to use a patch cord from here to there, locally. Any question? Okay, sorry. Yeah. The next items is the RIO. RIO is audio interface with 16 input and 8 output. If you remember, we have 2 input and 1 audio output. Then we have on 6 floor box, we have 2 audio input for each floor box. And then the floor box are directly connected with the front connector. The first 2 here are floor box 1, line 1 and 2, as you can see, up to input 12. The last 1, 2, 3, 4 are not connected. Not connected means not used, simply are not connected. You can connect anything there, and this audio goes to the Dante network. Then, let's say an example. I can connect a microphone here, and this audio can go directly on the audio mixer in EQR1. because Audio Dante network is comprehensive from EQR2 and EQR1. That means not necessarily everything is connected here must go to the EQR2. Can go also on EQR1. Or you can send an audio from EQR1 to the auditorium through the rear. Considering that each box has two audio input and one audio output, we are using 6 audio output of the Rio to go to the box and 12 audio input of the Rio to go from the box to the Dante network. If you need to connect, for instance, a speaker audio in auditorium, for some reason, we don't care about that, you may use one of these output depending where you want to put your speaker. Near floor box 1, 2, 3, 4, 5, 6. And then through Dante, send audio to this speaker. It's a very flexible system in any way. Any question? Oh, yeah, there is one thing that it is important. Uh, Rio can accept also a direct microphone input. So each input can be set for line level, which is 4 plus 4 dBm, or microphone level, which is minus 60 dBm. Rio also allow the connection of a microphone with the phantom, with external power. So what does it mean? It means that if on this connection on on a floor box in auditorium you want to connect a microphone, you can connect a microphone. This microphone goes to the Rio input. Rio input is able to drive the microphone, and then the audio from microphone goes into Dante and then can be listened everywhere, including in the amplification system, sorry, of the auditorium. Any question?
It's okay.
Okay. Now we have, sorry, just a minute. As we have already seen into the floor box, we have also some video connector, BNCs. These BNCs are not connected to the backstage, but are connected directly to the video patch panel in EQR2. Are lines which are working only in HD maximum 3G, not 12G, and are bidirectional lines. What does it mean? Means that the patch panel where these lines are connected is not normalized. It's a single patch panel. That means this connection is not connected with the upper one. It's always alone. And why we say is bidirectional? Because what we have there, it's just a pieces of wire without any direction. Then on the same wire, today I can receive a video from Floorbox. I send a video from Floorbox to the EQR2. But tomorrow I can reverse the situation. I can send a video from EQR2 to the Floorbox number 1, line 2. Because this one is just a pieces of cable and I can do anything I want. This is why I call it bidirectional video lines. It's just a connection limited to HD 3G. If you need to send 12G signal, you need a fiber with converter. Again, maybe you need a converter just in auditorium because you can connect a router fiber out directly to the auditorium. Then you need just to convert from fiber to video locally into the auditorium near the floor box. Any question?
It's
Okay.
okay.
Hello?
It's okay. Thank you.
Okay. Different condition we have for the Ethernet cable. We have on each floor box, we have two Ethernet connection goes to the backstage. And on the backstage, we have all the connection on the patch. And then we have two lines which goes to the EQR2. This must be intended as temporary emergency line. What does it mean? It means if you have the requirement to connect temporary a computer or just an equipment and control it and check it. If you have the requirement to have a continuous connection with a large bandwidth between EQR2 and auditorium, maybe in the future, it will be better to install a Ethernet switch. But it is not provided now because there is no any evidence that we need it. Now, this is a very important chapter about the SMPTE. So, this SMPTE cable are directly from EQR2, not from backstage. In EQR2, maybe you can check this afternoon, we have the last rack, number 5, which has installed in it 8 BPU and 8 CCU. So, the first 4 BPU and CCU are connected straight and fixed with the 4 PTZ camera 1, 2, 3, and 4 mounted on Shotoku system. BPU and CCU 5, 6, 7, and 8 are connected through the SMPT cable with an SMPT box, looks like this one, which is positioned on the rear of rack 5. So that means from this SMPT box, there is a 3-meter cable from this connection to the BPU. for BPU 5, 6, 7, and 8. Then we have other boxes on the rack number 5 on the rear with connection from the floor box. The first two connections are from floor box 7. The other two are from floor box 8. The other two floor box 9. So that what does it mean? That with 4 short cable, 1 meter cable, SMPTE, we can connect any position in any floor box to any camera. In this example, we have on BPU number 5, floor box 8, position 1. On BPU number 6, we have floor box 7, SMPT cable number 1. On BPU number 7, we have floor box 11, SMPT number 1, and floor box 10, SMPT number 2, connected to the BPU number 8. This is fundamental because if you remember, I told you we have 4 fixed camera in fixed position, but we have also 4 camera mounted on a tripod, and you can put the tripod anywhere in the auditorium. That means we must have the possibility to connect any camera to any BPU according to our requirement. And this is the way. Is it clear or not? Question?
It's
Hello?
okay. I showed them already this one yesterday.
Okay, it's clear.
I think yes.
Okay. This is the rear of the rack number 5. As you can see, we have 4 connection. This one is, so let's start with the last one, which is easy. This one is BPU number 8. This one is BPU number 7. This one is BPU number 6. And this one is BPU number 5. Other connection are from floor box. Then just I connect one cable here to there, and I have connected a floor box to a BPU. Then I can connect camera in that point. Okay?
Yes.
Okay, perfect. These are picture taken on the multi-viewer connection on the rear of the rack and EQR2 router connection. Just to show you that we have BNC, fiber, and SFP with micro BNC, exactly as we have in EQR1. Please take a note that the SFP micro BNC for the router are identical to the micro BNC for the multi-viewer. If you are in trouble, you can do a test. Just simply exchange the SFP from here to there or vice versa to find out which is working or not, are compatible. These are the multi-viewer configuration that we have in CR2. This is on the multi-viewer video desk. Where again, as we have in EQR1, some position we have a fixed position. Maybe this one, camera 2, 3, 4, 7, 8, 5, and 6 are fixed position. So in that position, we have a fixed camera. We cannot have other picture. In some other position, sorry, in some other position, like this one, we have router 1 out. What does it mean? Means that normally we have a router 1 output shown on this monitor. But on the router 1, normally is routed multi-viewer 1 input 13. But on this output, we can route any video that we want. So this is the reason why some position are fixed, and on some position we have a router output which can contain anything. And of course, why we have that? Because depending on the event, so maybe in some condition we need to see some device, and with another event we need to see a different device. This is the reason why we have some position with which can be changed. This is for the camera desk, and this is for the audio desk multi-viewer configuration. Yeah, this is very important. Give me a second, please. Okay, now we have a camera schematics, which is just to show you uh, what I was saying before about the camera. Yeah, this is okay. As you can see, camera configuration, it's very similar or identical at schematics level to the configuration in EQR1. We have four camera on PTZ with the converter from SMPTE to fiber. Then we have a converter here. Then we receive SMPTE, which goes to BPU. BPU through the SMPTE goes to the CCU. Then we have three output from the camera for the video switcher, for the router, and for the multi-viewer. And then we have an HD output on the patch panel for test and menu to see the menu of the camera. We have audio output. Again, on the camera, on the PTZ, there is a 15-pin connector that you can connect on the rear of the camera and connect a microphone. Then we have the output here, which goes directly to the audio mixer. But in this case, we have 1, 2, 3, and 4 camera PTZ with the same configuration. And then we have 4 camera on real SMPTE connection. Then we have a cable which arrives SMPTE cable through the SMPTE box, arrives directly to BPU number 5, 6, and so on. Configuration is the same, BPU and CCU, but the converter is not connected because we have SMPTE cable, real one. This is a very important thing because On the 4300 camera, the tripod camera that we can move around the auditorium, we have the possibility to connect directly on the camera with an audio cable, traditional one, XLR, a microphone. That means you can put a camera near the stage with the microphone attached, and then you can do an interview directly, and the audio output from the CCU goes directly to the video mix to the audio mixer. In this case, you have not to provide a special connection with the 15-pin connector or whatever. You have just a microphone input on the camera, ready to use. And you have ready to use the output to the audio mixer. This is valid for any of the 4 tripod camera. Again, in the auditorium, if you remember, we have also a wireless camera configured exactly as we have in pre-roll. The schematics is identical, and the way how it works, it is exactly the same. Any question?
It's okay.
Okay. Please, Marco, can you exchange on the other? Yeah, thank you. So this show you the device location, and you can see, of course, this device also in auditorium. But just to show you that we have a Creo antenna here in this position, which send data back to the video, the RF, the radio camera on the entire area. This small antenna is able to cover the entire area. We have the radio cam antenna divided in one section and the other, because if we close the 2 area and we have 2 separate area, even in that case with the camera, we can use the radio camera in this side or in this side, or one camera here and one camera there. Question?
Ah, it's okay.
This is Bolero antenna in the auditorium, PTZ Shotoku, and this is small one, not visible, Creo antenna in the auditorium. And this is the camera that I show you, that I explained to you before, mounted on a tripod. On this camera we have SMPT connector, which should be connected to any floor box that we have there. And on the rear we have some input, as you can see, 2 input, audio input. This audio input can be set line level or microphone level. Then you can connect a microphone here, or the camera has also a connector, a microphone connector in this position, where you connect the microphone here. Is selectable. There is a switch which asks you front microphone or rear microphone, but you can connect the microphone. Then the audio goes embedded on the video through the SMPT connector to the BPU, to the CCU, and the CCU audio is extracted and goes directly in analog mode to the audio mixer. And we have finished for today. Any question?
Maurizio, please. About SMPTE cables,
Yeah.
how many cables we have for the GMA project? And what's the distance of these cables? Because I see the camera here in our room. It's not connected with SMPTE. Normally, SMPTE, it's more better. Why we use power and BNC cables? It's because of the distance or what?
No, no. If you ask to Marco, it's better. We'll explain you exactly which is the connection. It's not a problem of distance because through the SMPT you can do 1/2 kilometer. Not a problem. Not a problem at all. Maybe is connected differently because Marco is going on the computer. It's this is not a video installation what you see now, but it's a multimedia installation for use Skype, and I think he does that for this reason.
And
I
we
think.
have in the GMA tall cable, for example, 20 meter, 30 meters, SMPT, SMPT, already prepared.
I think there are two cable 15 meter and two cable 25 meter for the 4 camera. Hello.
Yes, it's clear. Thank you, Maurizio.
Okay, okay, no problem. But of course, please ask Omar or Marco where the cable are. I don't know. Sorry.
Yes, no
Somewhere in the
problem.
store, but I don't know where exactly.
Thank you very
Um,
much, Maurizio.
no problem, no problem. So for today we have finished. Hope to speak and see you also tomorrow. Okay. So thank you. Bye.
Thank you.
Thank you.